in the figure at left, I pasted it up here, point O is the center of a circle of radius 1.5. We see that right over there. The missing sector of the circle has the missing sector of the circle has central angle AOB equal to 2 pi over 3 radians. That's this right over here, and that's the central angle for the missing sector right over there. What is the length of arc ACB? Now ACB is this arc. It's kind of the rest of the circle, the part that's not missing. So this is ACB right over here. Well, the way that I would tackle this, I would think, well, what's the circumference of the entire circle? And then what fraction of the entire circle is this arc length? So let's first think about the circumference of the entire circle. Circumference is equal to 2 pi times r. In this case, our radius, is 1.5. It's going to be 2 pi times 1.5. Now 2 times 1.5 is 3. And so this is going to be equal to 3 pi. So the circumference of the entire circle is 3 pi. And now there's a couple of ways you could do it. You could figure out, well, what is the length of this arc right over here, and then subtract that from the circumference, and then you'd be left with the magenta part. Or we could figure out the central angle of the magenta part. We could figure out this angle and think about, well, what fraction is that going to be if we were to go all the way around? And if we're thinking in radians, going all the way around is 2 pi radians. So what fraction is this angle of 2 pi? And then that's going to be the same fraction that this arc length is of the entire circumference. Well, what's this angle going to be? Well, it's going to be, if we went all the way around, the circle, that'd be 2 pi radians. But if we want to figure out this magenta central angle, it's going to be 2 pi minus this 2 pi over 3. So this is going to be 2 pi. Let me do it in that magenta color. So the central angle for this piece of the circle, that's kind of the central angle for ACB, is going to be 2 pi minus 2 pi over 3. I'm going all the way around, but then I'm subtracting out this part right over here. Now what's 2 pi minus 2 pi over 3? Let's see, I can find a common denominator. Instead of writing it as 2 pi, I can write that as 6 pi over 3. So let me do that. It's going to be 6 pi over 3 minus 2 pi over 3. Well, that's going to be 4 pi over 3. 4 pi over 3. So once again, this angle right over here is 4 pi over 3. 4 pi over 3 radians. Now, what fraction is that of if we were to go all the way around the circle? Well, once again, this central angle is 4 pi over 3. If you were to go all the way around the circle, that's 2 pi. So this is the fraction of the entire circle that this arc represents. And so let's just multiply that times the entire circumference. Times 3 pi. And let's try to simplify it. Let's see, we have pi divided by pi. And let's see, if we take this 3 and multiply it times the numerator, this 3 is going to cancel with that 3. And we're going to be left with 4 pi over 2. 4 pi divided by 2 is equal to 2 pi. So that's the length. That's the length of this arc. So it's actually exactly 2/3 of the entire circumference. So let me just select that, 2 pi. And we're done.